two solutions. Just add them together, but make sure they're real solutions. Okay, so going to factor this, I'm going to move the 12 over. Let me experiment. I'm going to see if I can type in. This is being done with screen capture software. There it is. Oops, I need to know what the heck that was the original equation. Can I scan that? I don't think I can. Let's try it. Maybe this won't work. Oh, it did kind of. Well, when I go to factor this, I'm looking for two numbers that multiply to make x squared. So that's going to be x and x. When I move this 12 over, let me see if I can do that. There we go. Now I've got that equal to 0. And so I've got a negative. So I'm looking for two numbers that multiply. Ooh, let's double check that. That looks like that. Could that be a typo? That would be bad. Nope, that's a negative 12. So when I brought it over, that becomes a positive 12. No typo, just careless work on my part. So that's a plus 12. Two numbers that multiply to make 12 that add up to make negative 13. Add up because that's a plus right there. That is a negative 12 then, and a negative 1. Those will multiply to make a positive 12 and add up to make negative 13. So the actual solutions then would be 12 and 1. But I add them up and I get positive 13. That's my answer. Positive 13 right there. Okay, solve the following by factoring when you have the two solutions. All right, so this is a box method one. This is going to be a little bit tougher. Maybe I can talk my way through it. The box method works by multiplying the first term times the last term. That gives me a positive 60x squared. Then, because this is a plus right here, I'm looking for two numbers that multiply to make that 60 that add up to make negative 19. I think that is 15 and 4. You could systematically go through and make a list, but negative 16 and negative 4 multiply to make a positive 60 and add up to make negative 19. Then I take that factor and I combine that with, for instance, my 10x squared and my 15x. They're both negative, and I can throw out a 5. So I get 2x minus 3 for one solution and 5x plus 2. So I'm writing this down off camera. 2x minus 3 and 5x minus 2. That will give me solutions that are 3 halves and then 2 fifths. 2 fifths. So when I get a common denominator, that would be a 10, and it would be 15 plus 4 over 10. That is 19 tenths, so that's that one. Okay? Sorry I can't show you the work. Question 6. When deciding to use extracting the root method, you would look for the equation where the x squared term has no coefficient. Has a coefficient. That will make it harder, so that's not so good. The x squared term has no coefficient. That might make it easier. But the key thing is the x can appear only once, and it's in a parentheses that's being squared. Okay, solve the following by extracting the square root. Okay, this is where we peel it away layer by layer. We're going to do the outermost layer first. I'm going to take away 15 from both sides. That makes that, or take away 5 from both sides. That makes 11. There is 11. Then I get rid of the 1/2 by multiplying by the reciprocal. That's really the same thing as dividing by 1/2. And so 11 doubled is 22. When I take the square root of both sides, I get the square root of 22. That does not simplify. If you do your factoring, it's just 2 and 11. No pairs to take out. Then I would subtract 3. So it becomes minus 3 plus or minus radical 22. And then it's all over 10. So the quadruple then would be minus 3, comma, and then 1, comma, because it's outside the radical, and then 22, comma, and then 10. I can't simplify that factor. Okay, keep our fingers crossed that that's right. No typing errors, no silly mistakes. And hope I didn't skip a question there. Fill in the blank for the completing the square. Okay, completing the square is nothing more than looking at this b term, cutting it in half and squaring it. So that's 100. Question 9, also completing the square, but this time I'm actually going to solve this problem by completing the square. So again, I wish I could easily show you how to do this. I am going to, I can try that, 5x squared plus x minus 2. 5x squared plus x minus 2. So 5x squared plus x minus 2, and that equals 0. So what I'm going to do is I'm going to bring this 2 over to the other side and make room for a blank. And so that would be over there as a positive 2. How do I complete the square? Well, I can't do that until I divide by 5. I could have divided by 5 and then move things over. When I divide by 5, that's gone. This becomes 1/5, and this becomes 2/5. And then maybe I can just cut and paste. Then the next step will be to complete the square. Well, how do I cut 1/5 in half? What I do is I either cut the top in half if it's even, but I can't, so I have to double the denominator. That's 1/10. Then when I square 1/10, it becomes 1/100. Oops. And then I add to that the other side, the same thing. All right. Then I know that will give me the perfect square, which I'm going to attempt to do quickly this way, where it is going to be x then inside. It's going to be half of this 1/5, so that's going to be plus then 1/10, and that's squared, and that's going to be equal to then this fraction when I add it. Well, 2/5 is the same as 20/50, which if I double top and bottom makes it 40/100. So this becomes 41/100. 41 divided by 100. Check that on your calculator. When I take the square root of both sides, this becomes just x plus 1/10, and then the other side becomes the square root of 41. I'll just call that root 41, and then when I take the square root of the bottom, it's over 10. I then subtract that from both sides, so x then will be equal to minus negative 1/10, and then plus or minus then root 41 over 10. So to type in the answer, it's going to be minus 1 plus or minus root 41 over 10. So that's going to be 1 plus or minus root 41, 1 comma 41 over 10. I hope I got that right, and make sure the sign is correct. Oop, it's a minus 1/10. I'm glad I caught that. Always check your work. Better to be safe than sorry, so that's a minus out front. All right, hopefully that is good. Okay, quadratic formula stuff. We got -5, we've got 12, we've got -5 again. I would immediately multiply everything by -1. 0 times -1 is still 0, and then these switch to be positive. I think you'd make fewer mistakes with plus, -12, and +5. When I put that into the quadratic formula, it's going to be minus b. So this switches to minus, so now I'm going to make that be plus 12 then. And then plus or minus the square root of b squared, so that's 144 minus 4 times a times c. And those are both going to be pluses. That's 25, and times 4 is 100, so it's going to be 144 minus 100, which is 44. I can take out a 4, and that would be 2 radical 11, 2 comma 11, and then in the denominator is going to be all over 2a, which is 10. So hope that works. It's hard not to be able to work on paper. So, all right, 2 questions to go. Solve with a quadratic formula. All right, same type of thing, only different. I've got to do a little bit of moving around. This is going to be positive 2, minus 9, positive 4. The minus 9 then switches over, becomes a positive 9. And then inside the radical is 9 squared. That's 81 minus 4ac. 4 times 2 is 8, times 4 is 32. So what is that? 81 minus 42 is 49. 49 then is going to be square rootable, so I get 7. So I get exactly 7. So it's going to be 7, and then under the radical is 1. And then down below is 2a, which should be 4. Okay, I'm going quickly. I hope I did that mental math all right. 81 minus 42. 81 minus 2 is 79, minus 4 up is 39. 39 is 3 times 13. Oops, so no, that is not right. So that is going to be 1 comma 39. 4. All right, hope that is correct. I'm going to keep going because even if it's wrong, you guys can help by doing it, or you guys can verify by doing that on paper. Here we go. Last one, a word problem. The product of 2 consecutive positive numbers. The product of 2 consecutive positive numbers. That's an x times an x plus 1. That will give me x squared plus x. Added to the larger number, okay, plus x.